Hello again, everyone. This is Mr. Smith, and this is 1.23 factored form. This is usually where students have the most trouble. However, just bear with me, and we will get through this. Okay, so factored form is going to look a little something like this. Y equals A. That A value is the same as like factored form. It'll stretch or compress or reflect it across the x-axis. Then we have two sets of brackets. First set has x minus p. Second set has x minus q. What the p and q are the zeros. And what's important to note here is positive p and positive q are the zeros. Notice how in the formula it says minus p minus q. That means the opposite sign of whatever is in the brackets. So I'll elaborate that a little bit further into the lesson. Our step pattern, just a quick review, should be A times 1, 3, 5, 7, and so on and so forth. Just the A value times that. The direction of opening depends on the A value. If A is greater than 0, it's up. If A is less than 0, it's down. The vertex will be, well, this is actually new. The X value will be halfway between P and Q. This is always true. It's the halfway point between your two zeros, if there are zeros. We're going to assume for the time being that there's always zeros, but we will likely come across something where we don't have any zeros. But for today, we're just going to assume there's both zeros. And once you have both of the zeros, P and Q, you add them together, divide by 2, take the average of them, and that'll give you the halfway point, and that'll be the X value. Now to solve for the Y value, after you've found the X value of your vertex, you actually just sub it back in to solve for Y. So you sub in the X value into the equation to solve for Y. After you get the X value for the vertex, so say this is 5, you added 5 and let's say you added together, divided by 2, and you got x equals 5. So then you'd sub in 5 into the equation, the factored form equation, and then solve for y. Next, we're going to identify the zeros and the axis of symmetry, then the vertex. Remember the axis of symmetry, just recall, that is just x equals the value of your vertex, or the x value of your vertex. Okay, let's start. So we have x minus 2, x minus 5, and an easy way for me to remember what my zeros are is, because this can get confusing, is I have my bracket here, x minus 2. I want this to equal 0, hence the name zeros. 2 equals x then. So that's my first one. The next one would be x minus 5. I want that to equal 0. And then that means x equals 5. So my two zeros should be 2 and 5. If I reveal this, there we go, 2 and 5. Axis of symmetry, well, I take 2 plus 5 and divide by 2. You get 7 over 2, or 3.5. So it should be x equals 3.5 or x equals 7 over 2. There it is there, x equals 3.5. Now what you do is you sub your 3.5 back into your equation. So we have y equals 2 3.5 minus 2 bracket new bracket 3.5 minus 5. Then I end up with 2 times 1.5 times negative 1.5, which is just 4.5. So now I have, let's reveal that. There we go. And that's how you work through that. The next one I'm not going to, otherwise I'm going to run out of room. Same idea. My zeros, x plus 9. Well, x, that means that this is going to be negative 9 here. And this is going to be positive 3 here. Positive 3. There we go. So negative 9, positive 3 should be my zeros, and when I reveal it, I get negative 9, positive 3. To find my axis of symmetry, I add the two together and then divide by 2. Negative 9 plus 3 is negative 6. Divide by negative or divide by 2, we get -3. X equals -3. There we go. Now I sub in -3 into the equation. I have to be careful though, because a value has a negative, it's a -1. That means that when I'm multiplying it out, I have to multiply by -1 at the end. So -3 plus 9 is +6, and then -3 minus 3 is -6. So we get -36 times -1. We get +36 should be our y value. There it is there. Common factoring. Okay. Factoring is the opposite of expanding. So in this case, we're actually just going to take the common factor first. If we have 4x minus 12, we can take out a common factor of 4. Because the greatest common factor of 4 and 12 is just 4. We write the greatest common factor in front of the brackets. Divide each term in the brackets by the greatest common factor. So for the next example, we're just gonna factor the following quadratic relations using the common factors. We're not going to factor fully yet, we're getting to it. If I have 4x squared minus 16x plus 12, the greatest common factor in this case is 4, because they can each divide by 4. So this is example 2 we're working on. So you take out 4. So 4x squared divided by 4 becomes just x squared. Negative 16x divided by 4 becomes negative 4x. 12 divided by 4 becomes 3. Simple, straightforward. That's all there is to it. Our next example, we have 12x squared minus 75. The factors of 12 are 1, 2, 6, 3, 4, 12. And I think 3 is the highest number. Yes, it is. Okay, so 3 is the greatest common factor. You divide each term by 3. 12 divided by 3, or 12x squared divided by 3 is 4x squared. Negative 75 divided by 3 is negative 25. So that's where those numbers come from in the bracket. You just divide the terms up at the top by that number there. Our next example, we have to be a little bit more careful, because so far we've only seen common factors where there was no variables. In our next example, though, we have an x squared and an x term, which means x is going to be part of our greatest common factor. We also have 5 and negative 15. The greatest common factor between 5 and negative 15 is 5. And the greatest common factor of x squared and x is x. So 5x. We do the the numbers, and then we do the letters. So 5x should be our greatest common factor. If you divide 5x squared by 5x, you just get x, because you take a power of x out. If you take negative 15x and divide it by 5x, well, x divided by x cancels itself out. Negative 15 divided by 5 gives us negative 3. And that's how you take out a common factor. Next page, we have factoring quadratic trinomials. Okay, so this is the real meat and potatoes and everything else of this lesson, however you want to phrase it, because this is where things get interesting. We have x squared plus bx plus c. We're not taking common factors right now. We will learn more about that in later lessons to come. So far, for factoring quadratic relations, we're just dealing with the a value equal to 1. Okay. And the way to think about this is p and q. You remember p and q from our zeros. P times q is going to equal c. P plus q is going to equal b. So b is over here. It's our second term before we factor. It's our standard form second term. So p plus q is going to equal b. P times q, which is our zeros, when they're multiplied together, that'll equal c. A little bit confusing. It probably will make more sense with the example. There's the double bracket method. So find p and q. If P times Q, remember, P times Q is C. So this would be like the C value here. And this would be like the B value here. Now, I'm going to just work through this table with you, and then I'll show you what it would look like as a standard form quadratic relation. So, P times Q equals 8, P plus Q equals 6. I would say 4 and 2, because 4 and 2 added together gives us 6. 4 times 2 gives us 8. And this is tricky. It's very difficult to think of these just on the spot. Don't worry if you're not getting them as fast as I am. I've had years of practice. It does take practice, and it takes time to get to that point. P times Q equals 15. Well, we know 1, 5, 3, and 15 are the only factors of 15. So start thinking of the factors and which two factors will add up to 8. If you said 5 and 3, you are correct. And it doesn't matter which order these go in. It could be 3, 5, 5, 3. Either way, you're going to get the right answer and your math is going to work out. So that's not a big deal. Next, we have negative 10 and 3. Multiplies to negative 10, adds to 3. So one of the factors is going to be negative, one's going to be positive. All the factors of 10 are 1, 2, 5, and 10. What two of those numbers, of those factors, add to 3 if one is negative, one's positive? If you said 5 and negative 2, you are correct. Or if you said negative 2, 5, that's also correct. Good job. Okay, now we have negative 9 is our multiplication, and negative 8 is what we add to. What two numbers? Well, let's consider the factors of negative 9. Factors of 9 are 1, 3, and 9. Which of those, and it could be any combination of the two, will add to negative 8? Keep in mind, if you're multiplying and you get a negative number, that means one's negative, one's positive. So, if you said negative 9, positive 1, or 1 positive, or positive 1, negative 9, then you are correct. Next example, we have 14 is what it multiplies to. There's not a whole lot of numbers that multiply to 14. 1, 2, 7, and 14 are the factors of 14. Those are numbers that it can be divided by. And it adds to negative 9. Now, when you're thinking of this, if it multiplies to a positive number, the signs of the zeros are going to be the same. That means that in this example, it multiplies to a positive number, but adds to a negative. That means both of the factors are going to be negative. So if we consider negative 1, negative 2, negative 7, and negative 14, which of those two will add to negative 9? If you said negative 7, negative 2, you are correct. Good job. Or if you said negative 2, negative 7, that's right as well. Next example, we have negative 9, but it adds to 0. Well, this is a little tricky. The factors for negative 9, or for 9, are 1, 3, and 9. What adds together, one's positive, one's negative, to get you 0. 1 and 9 don't add together to get you 0. I might have to think about this. Keep in mind, you can use the same number twice, as long as it multiplies to 9, or negative 9, and adds to 0. If you said 3, negative 3, good job. Excellent work. That is exactly it. Or if you said negative 3 or 3, that is also correct. Doesn't matter the order, like I said. Next example, we have multiplies to 0, adds to 5. It's a trick question, and it's a lot easier. Don't overthink it. You're going to laugh when you see the answer. What multiplies to 0 and adds to 5? And 5 is a prime number, so that means 1 and 5 are the only factors of 5. If you said 0 and 5 or 5 and 0, you are correct. Okay, now I'm going to go through some of these and show you what they look like as a standard form. In this case, we don't have, the a value is just 1. So I'm looking at this first line here. The b value is positive 6, right? Because that's our first, or our second column here. The first column is our c value. So we have bx, that's really a 6x, plus our c value, which is 8. Okay, now I'm going to do the next one. Remember, a value is still just 1 in this case. This is going to be x squared plus 8x. And I got the 8 from the b value here. That was p plus q. And then our c value is 15, so we plus 15 at the end. And that's the standard form. Let me jump down one more. So we did this one too. Now let's do this one. We'll do one more. X squared plus 3x. Because remember, the b value is over here, the second column. C value is the first column. So minus 10. Because that's, I'm just pulling the numbers from the first two columns of the table. If I jump down to the bottom two, because these are very interesting, I want to make sure I highlight these. So this one here, I have the c value of -9, but I have 0 for the b value, so I just leave that out, and this just looks like this. Same exact idea for this one. I have x squared, and then that's the b value plus 5x. And that's what those would look like as quadratic relations if we wrote them out in standard form. Now I'm going to show you what they look like in factored form. Remember, in factored form, I'm going to be using the last two columns. This is really just going to be x plus p plus q. So plus p, so that's plus 4, x plus 2. That's it. That's all there is to factoring. Next line, this would be x plus 5, x plus 3. Now this is obviously a lot more writing than I would make you do if you were actually just factoring in a standard form or in a standard method. This would be x plus 5, x minus 2. Oh, that's a bracket at the end there. X minus 2. If you wanted to double check your work, you could expand using FOIL, and you should get the original equation at the start. If I were factoring this one down here, I'm going to do the last two rows. It's x plus 3, x minus 3. Pretty standard stuff. This last one here is interesting because we have x plus 5, and then x plus 0. However, you don't have to write plus 0, so it just becomes x times, I flipped the order here, and there you go. If you expand it out, now if you expand it out, you should see the original equation, x squared plus 5x. You can always double check your factoring and see if it's correct by expanding. And you guys know how to expand, so that works out quite well. Our next example says factor fully. Remember, this is b, this is c. We're going to multiply to get to c. In this case, this is how I usually set this up. I call it the man method. And the reason why is because m for multiplication, a for addition, n for numbers. So what multiplies to 18 adds to 11. Well, the factors of 18 are 1, 2, 3, 6, 9, and 18. Oh, my brain hurts today. So what two numbers add to 11 but multiply to 18. Remember, you can only work with the factors. And in this case, if you said 9 and 2, you are correct. So when you factor it, it should be x plus 9, x plus 2. Perfect. And you don't have to do this every time. I prefer if you do. Remember, I can't give part marks if you're not showing your work. Our next example, if I do AN again, and I have 12. What adds to negative 7 and multiplies to 12. Now remember, if we multiply to a positive number, that means that the two numbers are going to have the same sign. And since it adds to a negative number, that means both of the numbers are going to be negative. So what two negative numbers multiply to 12 but add to negative 7? Keep in mind the factors of 12 are 1, 2, 3, 4, 6, and 12. What two of those numbers will add together, or subtract in this case together, to get you negative 7? If you said negative 3, negative 4, then you are correct. So you should have x minus 3, x minus 4 in your brackets here. Same idea for the third example. What multiplies to negative 18 adds to 3, and what are our numbers? If it multiplies to a negative number, one's negative, one's positive. What two numbers, what two factors of 18? Remember, our factors of 18 are 1, 2, 3, 6, 9, and 18. What two numbers are going to add to 3 but multiply to negative 18? If you said 6, negative 3, you are correct. If we reveal, you should have 6 or x plus 6 and x minus 3 in our brackets. Next, we have find the zeros of the quadratic relations. The same idea, exact same stuff. Factor first, and then it's the opposite sign of the P or Q, and I'll kind of explain how to do that. First, let's factor. What multiplies to negative 21 and adds to positive 4? If it multiplies to negative 21, adds to 4, what are our numbers? Remember, it's negative, so that means that one sign is going to be negative, one's going to be positive. The factors of negative 21 are 1, 3, 7, and 21. What two numbers add together to give you 4 and multiply to negative 21? So keep in mind, if you said 7 and negative 3, you are correct. So now we reveal our factored form here: x minus 7, x plus 7, x minus 3. There we go. Now, whatever x value will give you 0 inside the bracket. So if you have x plus 7, that means that x equals negative 7. If we have x minus 3 equals 0, we have x equals 3. There we go. Our zeros are negative 7, like I said here, and positive 3, like I said over here. Next example, what multiplies to negative 12, adds to negative 1? Remember, if there's no number in front of the x, that means that there's just a 1 there, and if it's negative 1. What two numbers multiply to negative 12, add to negative 1? Keep in mind the factors of 12 are 1, 2, 3, 4, 6, and 12. And because the multiplication's negative, one's going to be negative, one's going to be positive. If you said negative 4 and 3, then you are correct. When you factor it, you get negative 4 and positive 3 in the brackets. Now we need to set the brackets to equal 0, so x minus 4 equals 0, which means that x equals 4. That's one of our zeros. And if we have x plus 3 equals 0, then we have x equals -3. So -3 and +4 should be our zeros. There it is right there. Perfect. All right, that should be enough for you guys to move on to your assignment 1.23. This is a tricky concept. Make sure you ask lots of questions in the forum. We will be doing this as well in the next lesson. Good luck, and I will hear from you guys, I'm certain, soon. Okay, bye.